So today we are going to discuss about the enzyme inhibition. There are many questions which are asked in the exams. So what is enzyme inhibition? It is a process where the inhibitor molecule is binding to the enzyme and reduces its activity. The inhibitor can bind to the active site of the enzyme as well as bind to the other site than the active site, which is also known as the allosteric site, and can reduce its activity. So this could be reversible where the inhibition stops if the inhibitor is removed, or irreversible where the enzyme is permanently damaged. Common types of the reversible inhibition include competitive, non-competitive, uncompetitive, and there is one more inhibition which is a mixed kind of inhibition. So we are going to discuss them one by one. So first of all, we will discuss about the competitive inhibition. In any kind of innovation, there are two questions which are usually asked in the exams. What is the effect on the Km, and what is the effect on the rate of the reaction, which is the maximum velocity? So what is Km? Now we will understand what is Km. So Km is the Michaelis-Menten constant, and you have seen the graph. This is like this, and if this is like this, you can say here on the x-axis, if it is a substrate concentration, and on the y-axis this is the rate of the reaction or velocity, and let's say this is the maximum velocity Vmax, because after that there is a drop down. So the concentration where velocity of the reaction is Vmax by half, that is known as the Km. So what is Km? Km is the substrate concentration where velocity or the rate of reaction is Vmax by half. So this is like what is Km, and Km is also known as the Michaelis-Menten constant. Okay, so in the presence of competitive inhibition, basically uh, what happened, this is suppose your enzyme, and this is suppose your substrate, and this is suppose your inhibitor. Both are binding, both are competing for the same site, which is the active site. In the case of competitive inhibition, so both are competing for the same site. It means what will happen if you write the reaction, it will be like E plus S, this will form ES, and then it will form its product, right? Inhibitor is binding to the same site where the substrate is binding. Okay, so what will happen, this enzyme will require more substrates concentration to move it forward, right? So more substrate concentration, and Km is what? Is the substrate concentration at which V is equal to Vmax by half. So because inhibitor is present, this enzyme will require more substrate concentration to move it forward, and therefore the Km is going to be high in this case. And when the Km is high, it means the enzyme has low affinity for that substrate. So affinity of the enzyme towards the substrate is going to be less. Affinity of enzyme for substrate, it is going to be less. So you can say Km is directly proportional to the substrate concentration or indirectly proportional to the Let's say if we are denoting it by AF, affinity of the enzyme, then this is indirectly proportional to the affinity of the enzyme. So it is like that. If you have any interest in any subject, you need less input. So if the enzyme has high affinity for the substrate, then enzyme need a minute amount of substrate to move it forward. But if the enzyme has low affinity, then it means because it has low affinity in the presence of inhibitor, it require more substrate concentration, and because of this, what will happen? Because of this, the Km is going to be increased, or you can say the affinity of the enzyme to the substrate is going to be less. Okay, by this formula you can remember it. Now, what is the effect of Vmax? So what happened? The formula of the Michaelis-Menten constant is Vmax S Km plus S. Sorry, V is equal to, this is V. This is the formula. So now you can see if S is very high, then what happened? You can ignore this Km. If suppose the substrate concentration is very much high than the inhibitor concentration, then you can write this formula as Vmax S by S, and S is going to be cancelled, so V is equal to Vmax. It means rate of the reaction is not going to be changed in the presence of inhibitor, which is showing the competitive inhibition, or you can say which is binding to the same site where the substrate is binding. So two things which you need to remember in this, because inhibitor is binding to the same site, enzyme needs more substrate, and because the enzyme needs more substrate, it means the Km is going to be high. But there will be no effect on the rate of the reaction if you are adding very high amount of substrate in comparison to the inhibitor, then your velocity of the reaction is not going to be changed. So you can write like this: Km is high and Vmax, maximum velocity of the reaction, or the velocity of the reaction, there is no change in the presence of competitive inhibitor. Now coming to the second point, which is uncompetitive inhibition. So what happened in the case of uncompetitive inhibition? Again you will write the same formula, E plus S is going to form ES, and then it is going to form E plus P, and here the inhibitor will bind to only the enzyme substrate complex. Okay, so before we move forward, I want to tell you one thing, which is this thing. What is the total rate of the Vmax? It could be. What is a kcat? Which is the turnover number. It means turnover. It means how many molecules of the substrate is going to be converted into the product per second by the enzyme when it is fully saturated. So this is the maximum capacity of the enzyme. So if suppose the kcat is 100 seconds, it means each enzyme molecule make 100 more product molecules per second when it is fully saturated. Okay. So total rate of the reaction depends on the rate per enzyme, which is the kcat, or the turnover number, multiplied by the number of enzymes. Here you know the kcat is 100, and if you know the number of enzymes, you can calculate the total rate or the Vmax. Total rate is the Vmax. Rate per enzyme is the kcat, or which is the turnover number, and number of enzyme is the total enzyme which is present in your assay. It's in the molarity. Now if you see, Now you see that this inhibitor is binding to the ES complex. It means the Vmax is going to be decreased, because with the same formula you can say Vmax is equal to Kcat multiplied by total enzyme concentration in your assay. Because inhibitor is binding to the ES complex, then the product is not going to be formed. And because the product is not going to be formed, the total enzyme concentration is already going to be decreased. So Vmax is basically is going to be decreased in this assay. Okay. Now what is the effect on Km? Here, when this particular inhibitor is binding to the ES complex, the system will try to form more and more ES complex. So the reaction will move forward. And because the reaction will move forward, the Km is going to be less, or you can say the affinity of the enzyme towards the substrate will increase, and the Km is going to be decreased, because the affinity of the enzyme to the substrate is going to be increased, and in this case Km will decrease. So in the case of uncompetitive inhibition, where the inhibitor is binding only to the ES complex, the total enzyme concentration is, the total enzyme concentration is going to be decreased, and because of that the Vmax is going to be decreased, and because the reaction is not moving forward, the system will try to make more and more AES complex, and this will happen only when the enzyme has high affinity for that substrate. And as you know, Km and affinity is indirectly proportional, so the Km is going to be decreased. So in the case of uncompetitive inhibition, both the velocity of the reaction, or the maximum value rate of the reaction, as well as the Km is going to be decreased. Okay. Now I want to tell you one more thing, how you can do it by mathematical formula. For example, the formula is V is equal to V max S Km plus S. Okay. In the presence of inhibitor, it is going to be apparent Km, and apparent Km is equal to 1 plus I divided by Ki, where Ki, as you know, is going to be concentration of enzyme, concentration of inhibitor divided by Ei. Okay, so this is going to be your Ki. This is going to be your apparent Km. So in the presence of inhibitor, this basically you need to write alpha, and here you need to write alpha, where alpha is basically the value of alpha is going to be this thing. This is going to be alpha. Alpha is going to be 1 plus I divided by Ki. Okay. And you can calculate it also. For example, in the presence of competitive inhibitor, the total unavailable enzyme is E plus EI. Why enzyme alone, the free enzyme? Because enzyme cannot be free, because they are competing for the same site. And EI is already being engaged with the inhibitor, so substrate may not bind, or will, because it is already been consumed by the inhibitor. So total enzyme which is unavailable in the presence of inhibitor is this one. This is the total unavailable enzyme. Now you can substitute EI here. If you calculate EI here, you can rearrange it, and you will get EI by Ki. Okay. So we can write E plus E I by Ki. Okay. So if you will draw this line, you will get E is equal to 1 plus I by Ki. Okay. This is your total unavailable enzyme. You can say enzyme unavailable. Okay. Now you know Km is equal to Es by Es. Okay. For the inhibitor, it is going to be Ei or Ei, right? So you can just replace E values in the presence of inhibitor, and that is going to be E 1 plus I by Ki S by Es. And you know this is the in the presence of inhibitor, and I need to erase some portion. Okay, so you already know Km Es by Es, and this is your Ki, or you can say the apparent Km in the presence of inhibitor. It is going to be E 1 plus I upon Ki S by Es. So if you will divide both of them, you will get apparent Km. You can say this is the apparent Km. So if you will divide apparent Km by Km, you will get apparent Km is equal to 1 plus I by Ki into Km. And this value is known as the alpha. So alpha values is equal to 1 plus I upon Ki. Okay. So I can explain it one more time just to be remember. In the presence of inhibitor, the total unavailable enzyme is total free enzyme and the enzyme that is bound to the inhibitor. Total free enzyme, why it is unavailable? Because the same site will be competed by the inhibitor, so it will be unavailable. So E plus EI is the total unavailable enzyme, and as you know, E plus I is EI, so you can calculate the this K friend, which is EI by, divided by EI. So if you will rearrange, you will get this thing, EI by this one, okay, in the presence of inhibitor. Now you replace this value of EI here. So you will get E plus EI by Ki. So you will get E 1 plus Ki, which is the total unavailable enzyme. And apparent Km is equal to Es by Es. So you replace E with this value, which is E1 plus I upon Ki S by Es. Okay, this is your apparent Km, and Km formula is this. If you divide the apparent Km with the Km, you will get 1 plus I upon Ki into Km, where I 1 plus I, which is the inhibitor concentration, and Ki, which is the inhibitory constant. This is going to be your alpha. And what is Ki? You know this is the thing. Okay, so that is the basically I want to tell you. So what is the formula? If you see, V is equal to V max S Km plus S. Okay. Now, in the presence of inhibitor, this is going to be alpha and this is going to be alpha prime. Okay. So alpha is the affinity of the enzyme towards the inhibitor or afferent Km, and this is the affinity of the ES complex to the inhibitor. This is the alpha prime. So alpha here is going to be 1 plus I upon Ki, and alpha prime is going to be 1 plus I upon Ki prime. Okay, and where Ki prime is basically Ei is going to form E plus I. So Ki is going to be Ei divided by E and I. Okay. Okay. What is alpha? If you talk about alpha is E plus S is going to be Es. So Ki is going to be Es divided by Es. Okay. So what happened in the case of you know competitive inhibitor? Inhibitor is binding only to the, this is the formula, right? E plus P, and the inhibitor is also binding to the same site. Okay. So but the inhibitor is not binding to the ES complex, so this alpha prime values is just 1. So you will be having the value which is V max S divided by alpha Km plus S. Okay. So you can see the apparent Km is going to be increased in the presence of competitive inhibitor by the alpha value. So that's what we said. In the presence of competitive inhibitor, enzyme, because enzyme and substrate they are binding to the same site, enzyme will need more and more substrate concentration, and therefore the Km is going to be high. And in this case also you can say this is the factor of alpha Km. Let's say when the substrate concentration is very high, just ignore this alpha Km value. Okay, then what will you get? You will, when you will ignore this, then what will you get? You will get V is equal to V max S by S. S is going to be cut off out, so V is not going to be changed in the presence of competitive inhibitor. Okay. Now coming to the uncompetitive inhibitor, if we talk about, again we will write the same equation, which is the V is equal to V max S divided by Km, this one. Here in the presence of uncompetitive inhibitor, enzyme inhibitor is only binding to the ES complex. Okay, so you can ignore this alpha value and you will get V max S divided by Km plus alpha prime S. Okay, now you divide uh, this value by alpha prime. So what will you get? V max S divided by alpha prime divided by Km by alpha prime plus S. So Km is going to be basically decreased. Okay. So here you will see the Km, apparent Km in the presence of inhibitor is going to be Km by alpha prime. And what is the going to be the effect on velocity? If you see, you can again, in the presence of very high concentration of S, you ignore this value and you will get, this is your V value, right? So when you ignore this, this, you will get Vmax S by alpha prime into S, right? S is going to be cut off down. So Vmax is also going to be decreased. Okay. So in the presence of uncompetitive inhibitor, where the inhibitor is only binding to the ES complex, okay, and because it is binding to the ES complex, the total enzyme concentration is going to be decreased in the reaction because the reaction will not form any product. So in that case, as you know, the velocity of the reaction, as I said here, you can see in the simple language, it will decrease uh, because this E total enzyme in the assay is going to be decreased because of everything is going to be consumed by the inhibitor. So in that case, the Vmax is going to be decreased, uh, and because the reaction will move forward, so enzyme will have uh, high affinity for the enzyme, and because of that the Km is also going to be decreased, both mathematically and logically also this is going to be decreased. Okay, so both are going to be decreased. Now coming to the third one, which is the mixed inhibitor, mixed inhibition. So mixed inhibition, where enzyme is forming this ES complex and then it is forming E plus P, right? An inhibitor can bind to this site. It can also bind to this. So it can form EI as well as it can also form ESI. Okay. But the affinity of the enzyme to affinity of the enzyme inhibitor to the enzyme and the ES complex is not equal. So you can say alpha is not equal to alpha prime. In that case, what happened? In the mathematical term, if you will see here, so V is equal to V max S alpha Km plus alpha prime S. Okay, here alpha is not equal to alpha prime. So what will happen in this case? So in this case, what will happen? It will be like if you divide by alpha prime, you will get alpha by alpha prime Km plus S. So depending on what is the value of alpha and alpha prime, the apparent Km can increase or decrease. Apparent Km, it can increase or decrease. And what is the velocity? Again, when you are ignoring this value, again the V is going to come into, oh sorry, not this one. At a very high concentration of substrate, the value is going to be Vmax divided by alpha prime. So again the velocity of the reaction, or the rate of the reaction, is going to be decreased. Okay, so this is the mixed inhibition where the value of alpha and alpha prime is not equal because the inhibitor is binding to the free enzyme as well as to the ES complex with the different affinities. Okay, now coming to the non-competitive inhibition. Now this is the last one, which is a non-competitive inhibition. Here alpha is equal to alpha prime. So again if you will write the formula is V is equal to B max S divided by Km plus S alpha and alpha prime, and because alpha is equal to alpha prime, so you will be getting Vmax as Km, because alpha by divided by alpha prime plus s, right? And because alpha is equal to alpha prime, so you will be ultimately getting Vmax s divided by Km plus s, right? And here divided by alpha prime, right? We have divided this. So Km is not going to be changed. So in the case of non-competitive inhibition, Km is unchanged. However, again the reaction velocity is going to be decreased by Vmax by alpha prime when the substrate concentration is high. Okay, so this is like you have to understand like this. So this is the enzyme and this is the substrate. It is forming the ES complex, and then the inhibitor is binding to this much and forming the EI. Inhibitor is also binding to this one, this ES complex, and again it is forming ESI. Okay, again because the inhibitor is binding to the ES complex, the total enzyme available enzyme is going to be decreased, and because of that the V value is going to be definitely decreased. And because binding with the same affinity, so here the Km and here the Km value that will be generated will be nullified. Okay, okay, understand? Because here it will be having less affinity for the substrate because it is binding to the inhibitor as well. So less affinity means Km here it will increase, here it is going to be decreased, but these values are going to be same, and because of that the Km is not going to be changed. So in short, if we talk about in the case of uh, non-competitive inhibition, Km is going to be unchanged. However, the velocity of the reaction is going to be decreased in the presence of inhibitor. Okay, this is the apparent velocity. This is going to be decreased. Uh, Now, this is one line we were plot or double reciprocal plot where you can see the value of Km. Here you can see the Km in the presence of competitive inhibition. The Km is going to be increased, and here you can see in the presence of inhibitor this is going to be increased. And for the uncompetitive inhibitor, I think I pasted the same thing. But in the case of uncompetitive inhibitor, how you will get it like you will get the same thing, but it's like this. This is in the presence of inhibitor, and this is in the presence of no inhibitor. Because in that case, the Km is going to be decreased. So decreasing means minus 1 by Km is also going to be decreased. So this is in the presence of inhibitor, you will get this. And for this line, there is no inhibitor. So this will be the example of uncompetitive inhibition. Okay, so that's all for this today's lecture, and thank you so much.